Now let's look at annuities. Present value of an annuity. Let's say you have this, a very realistic situation. You're ready to buy a new car. You are driving around, shopping around, and you are choosing between three cars that you really liked. A Nissan, which costs $20,000, a Hummer costs $27,000, and a nice bright blue Porsche for $30,000. So these are your options, and you would like to buy one of these cars. You also know that you have no money at all. You're going to be taking a loan to fully cover the cost of whichever car you will be able to buy, to afford. But that will be determined by how much you can afford to pay per month on the monthly car loan payments, right? So a typical loan requires that you make payments back to the lender every month. And let's say your budget allows you to spend up to $600 per month on car loan payments. Let's say you have not the best credit score. Let's say it's 595. This table here, I found it on valuepenguin.com website. It shows the relationship between what kind of FICO credit score you have, like in which range you are, and for each range it shows what the annual interest rate would be on new cars if the loan is for 60 months, which is 5 years. So what is the interest rate for a 5-year car loan, depending on your credit score? In our problem, your credit score is 595. Where is it? It's in the range between 590 and 619, for which the corresponding annual car loan interest rate is 14.06%. So let's put all this information together and answer the question: which one of these three cars can you afford? The question is kind of vague. It doesn't really tell you what you need to calculate, right? So how are we going to approach it? Well, with your credit score of 595, the interest rate is 14.06% per year. The loan would be for 60 months. What would be the monthly interest rate on the loan? It will be 14.06% per year divided by 12 months. It gives 1.1717% per month. And we did this because since the loan payments are monthly, everything in our calculations must be monthly. Whatever calculations we'll be doing, everything should reflect the monthly frequency. Monthly interest rate, number of months, monthly cash flow. And what we can do is, how about we calculate what the maximum loan is that you can afford? How would we do that? We can do the following. Every month, how should we think about loans? What is a loan? Somebody gives you money today, somebody lends you money, a bank, right? Some lender. And then you will be paying it back in small pieces over many, many months, maybe even years, many years. But the lender will charge you interest, right? Okay. So in a way, the loan amount should equal the sum of all future loan payments that you will be making back to the lender in return. Except the sum should reflect the whole time value of money. So the interest rate should be somehow embedded in our summation. And the way it's done is we don't just add, we don't just do $600 times 60 months, right? We do, we discount each of the future monthly loan payment. we discount it back to today at, using the monthly rate and the appropriate number of months. For example, we don't just take the first $600 that we will be paying in 1 month and then add in the next one. The first $600 would need to be divided by 1 plus the monthly interest rate. So 1 plus 0.011717. The next $600 from the end of the second month is divided by the same thing but raised to the second power, and so on. And the last $600 in this sequence of a total of 60 loan payments is divided by the same term, 1 plus the interest rate, 0.011717 in decimals, raised to the power 60. Okay, so this is what you need to do. Very, easy, right? Well, not really. It will take you forever, right? It's very frustrating to have to calculate something like this. There are 60 terms in this sum. But don't worry, of course, there is a quick and easy solution to this. I'll show you 2 different shortcuts. The first one is the formula. It looks a little bit similar to the formula we had for an annuity future value. This is an annuity present value, the present value of all loan payments in our particular problem, which says take the loan payment, $600, multiplied by the reciprocal of the interest rate, so 0.011717. Then multiply that by, open parenthesis, 1 minus reciprocal of 1 plus the interest rate raised to the power 48, close parenthesis. That gives $25,751.77. If you go back, right, so just remember this number, $25,700 approximately. Which car can you buy for that kind of money? For that kind of money, you can only buy a Nissan, because that's the only, price that falls, under this loan limit, which was $25,000 and a little bit. You cannot afford a Hummer, a nice blue Hummer. You cannot afford a nice yellow Porsche, right? Unfortunately. Okay, so this is the formula, and it only covers the purchase of a Nissan. But of course there's another shortcut. You can do the whole thing in the financial calculator, and based on what we were doing in on the previous slides for annuity future value, you probably have already figured out what I'm about to do. Let's clear everything. Remember, the calculator was on the begin mode. Now we need to go back to the ordinary annuity mode, and resetting the whole calculator just takes care of that. So how do we find the present value of an annuity? The present value. Annuity means we need to use the PMT button. What's our payment? That's the loan payment that we will be making every month for the next 5 years or 60 months. So we put 600, we make it negative, we save it as our payment, the PMT key. How many of those will we have? We will have them over 5 years, but everything we are entering should reflect the monthly frequency. So 5 years is 60 months. 60 N. And the interest rate is also monthly, which is 1.1717, and then you press the interest per year button, I over Y. Compute. This time you're pressing the present value key, $25,751 and a little bit. That's only enough to buy, the cheapest one of the 3 car choices that you had. Right? So this is how you do it in the financial calculator. This is what I just did. There's actually another way of doing it. See how many different ways we came up with? There's a way to do it in the financial calculator using the cash flow keys. Maybe I should, open up this slide and do it here. So how else can we do this? We can use the cash flow keys. Let's clear everything. Start all over. Cash flow. What's cash flow 0? What kind of payments are we going to be making on the loan? We're not going to make anything right away. We can wait a month before we pay the first $600. So we save it as $0. We keep it as is. We press enter. Down arrow key. What's our first cash flow? Cash flow 01, the first one in the future. That's the first $600 payment. You put 600, keep the sign as positive, enter, down. What's the frequency of it? Now you can actually change the frequency. How about we make it 60? This is exactly how many times in a row we have the same exact cash flow, right? We are going to be paying $600 60 times in a row, consecutively. Same number every month, over and over and over for 60 months. So when the display asks you for the frequency, which is set to 1 as the default, you are going to change it to 60, press enter, and then the down arrow key. What's cash flow 02? Is it $600 in the second month? No, you actually don't need anything anymore. You're done. You have just entered 60 identical cash flows, right? We are done with all cash flows. There is no more. And now you press the NPV button. It asks you for the interest rate. You put the monthly rate, which is 1.1717. Enter, down, compute. Same answer. $25,751 and a little bit, a few cents. And again, I show both financial calculator methods on this slide. So, either one is okay to use. You can use the one with the payment button, or you can use the cash flow keys. It's completely up to you. Everything gives the same answer. In fact, let's check something. So let's go to this website. It's Bank of America. Somewhere on the Bank of America website, you'll find, actually, let's go to the original page. Bank of America website. Auto loans. Click here, auto loan calculator. This is where you want to be. Total loan amount. What was it? Total loan amount was let's move it here a little bit. 25,751 is what we found, right? The term is for 60 months. That's 5 years. The interest rate, this is actually per year. What was it? 14.06%, right? Calculate payment. Exactly $600, right? $600 is the required payment on a loan in the amount of $25,751. So what I'm trying to say is that all of these formulas we are learning in this class, future value, present value, future value of an annuity, present value of an annuity, everything we are learning is real. There's nothing made up or simplified. This is exactly the formulas that banks use to compute your loan payments or anything related to loans and other things in finance. So I think it's kind of cool that now you know what's behind all those loan calculators that you see online. Now you can do all that yourself. Now you can walk to a bank, ask for a loan, bring your financial calculator, and they will be talking to you differently. So in general, when you have an annuity and you need to find its present value, essentially one cash flow at a time, you discount it back to time zero using the appropriate number of time periods. And then you're combining all individual present values. And the shortcut to that is the formula I already showed you, which says the present value of an annuity equals the annuity cash flow multiplied by 1 divided by the interest rate, then multiplied by open parenthesis 1 minus, then we are subtracting a fraction with 1 on top, and on the bottom 1 plus the interest rate, and that raised to the power 4, close parenthesis. So the present value of an annuity gives the value of it in today's dollars one time period before the first cash flow. See, there's like a delay here. The very first cash flow is not today, but it's with a delay, with a one time period delay. And we're going to come back to that later. What if it happens immediately? So this is the formula for the present value of a T-period annuity. And again, there is a table at the end of the textbook which gives the value for this present value interest factor on an annuity, which is everything in the formula but the repeating cash flow amount itself, for different combinations of interest rate R and time periods T. So there is a table in Appendix A.3 at the end of the book.